Okay, so yesterday and the day before, we were looking at our parent function of a quadratic equation, which would be something like f of x equals x squared. And we learned that the shape of f of x equals x squared was, what do we call this shape?
A parabola.
Parabola. Okay, so x squared is in the shape of a parabola. What else did we learn about these graphs that are parabolas?
The smaller, like if it's a decimal or like a fraction, it's more wider or more compressed.
Okay, where does that go?
On a graph. So f of like 0.5 x squared, that would compress it.
Okay, so if we multiply in front of x squared by a number smaller than 1, we compress the graph.
And also if it's a negative 2, it flips the parabola.
Okay, we also learned that if it was f of x equals negative x squared, this is going to make our parabola open down, right?
If it's a bigger number than 1, it stretches.
It stretches
Yeah.
the parabola. So if this is x squared, then 3x squared would be taller and more narrow, right? Taller is probably a bad word. It's more narrow. It kind of looks a little taller because we stretched it. Now look, where did all of those numbers take place? Everything that changed the shape of the graph was being multiplied in front of the x squared. Right? They were all in the position. And again, if you think back to our quadratic form that we looked at when we were factoring, everything we looked at yesterday and the day before was in the position of a. Right? It's being multiplied in front of the x squared as a coefficient. Well, today we're going to be looking at what happens when I add or subtract numbers to x squared. Does everybody see the difference here? This is x squared minus 4, and 2 days ago we were looking at negative 4x squared. So we're in a different place here with what we're doing. So let's go to our graphing calculator, and let's put in these two graphs, and let's see how they compare to each other. So, let's see, I'm going to pull up my graphing calculator. Okay, so we're going to click y equals. Make sure everything's cleared out of your y equals screen. The two functions we're wanting to compare are x to the second power. So we're going to click x to the second. And then we're going to go down. And let's try x squared. And this time we're going to have minus 4. So we're comparing x to the second and x to the second minus 4. Okay, once we have these, let's click zoom, and let's click 6 for a zoom standard look. So we're all looking at the same thing.
Changes the y intersection.
Okay. Okay.
It moves 4 spaces. Damn.
Okay.
That's what the y-intercept is.
So, heard a lot of good things. You can see here where it crossed the y-axis before. This blue graph is the graph of x squared, and the red graph is the graph of x squared minus 4. So you can see, we talked about the y-intercept moving down 4. What's another way we could explain that? It is the y-intercept, but it's also an important point on my parabola.
It's your
It is the
Yeah.
vertex. Remember, the vertex is where it reaches its lowest point or its highest point. So we have moved the vertex down 4. Alright, what about, did it shift left or right any, this minus 4?
It
No,
doesn't.
It just went down 4. So again, let's think of another point that's on our x squared. So right here's the point 1, 1. Right, this is a point on x squared. Well, if I go down 4, 1, 2, 3, 4, is this point on the new graph? X squared minus 4?
Yeah.
It is. What about the point at 2, 4 on x squared? I used to have a point at 2, 4. If I move it down 4, does it hit my new graph of x squared minus 4? So I've not stretched the graph or compressed the graph. I've literally moved the graph down 4. This is a translation or a shift, right? Going down 4. And it moves every single point on the original parabola down 4. Okay? Okay, so let's look at these two graphs without actually putting them in our graphing calculator. Again, we could put them in our graphing calculator to see for sure what it does. But if you guys had to guess, compared to our parent function, f of x equals x squared, what is the graph of x squared plus 3 going to look like?
It's gonna move up 3.
This graph,
It's gonna really look narrower as well.
Yeah.
it will look like it's narrower, but it's not narrower, so let's don't say that. You're right, it looks like it. This here is going to shift the graph up 3. Which means, where will my vertex be?
It'd be
3.
positive 3.
Well, vertex is an ordered pair.
Yeah, so
3, 0.
yeah, 3, 0.
No, 0, 3.
0, 3. It's on the y-intercept.
So remember, if I just go up 3, right, this is just my rough estimate, my bad drawing. If I go, I'm not going left or right anywhere. I'm only going up 3, so this is the ordered pair 0, 3. All right, what about my axis of symmetry?
It'd be still on the y.
It is still on the y-axis, but remember, our equation is always x equals a number.
X equals.
So what's the x value equal to here on the vertex?
0.
0. So this is still on that line for x equals 0. So it didn't move the axis of symmetry. That's what I'm wanting you to see. It moved the vertex up 3, but going up 3 does nothing to my axis of symmetry. It's still x equals 0.
Wait, what is that again?
The axis of symmetry,
Yeah.
it's the line where the parabola is exactly mirrored itself on either side. If you remember, if I have a parabola right down the middle,
Oh, yeah.
I can fold it over that line and it maps directly on top of itself. Kind of like when you're in elementary school and you drew a butterfly and you cut it in half. Right? That's what it reminds me of. So moving the graph up 3, right, it moved the vertex, but it does not move the axis of symmetry, is my point. It's still on that same vertical line. Okay, what about B? What's this going to what's going to happen to the graph on B here?
It's going to shift the graph down 2
Why? How do you know it's going to go down?
because it's a negative.
Absolutely. The negative 2 means we're going to go down 2. So this will shift the graph down 2. So same questions as before. Where's my vertex going to be?
Negative 2. 0, negative 2.
It's going to be at the ordered pair 0, negative 2. Right? It used to be at 0, 0, but now I've shifted it down 2. And shifting down 2, what does that do to the axis of symmetry? Nothing.
Still equals 0.
X is still 0. If I shift the graph down 2, the axis of symmetry is still in the same position. Okay, so now we want to know, how does the graph of g of x equals x minus 3 squared compare to f of x equals x squared? So, before we put anything in our calculator, what do we notice is different about this
We have-
kind of problem?
We have an exponent.
Well, there was an exponent in the last one, too.
We have a.
It's in parentheses, though.
It's not with
So here, the subtraction is happening, I call this inside the function. Right, we're happening inside the parentheses. For the last one, the subtraction or the addition was after the exponent. Right? So like the problem before, we were looking at h of x equals x squared minus 3. See how these are different? Like how they look different? Well, let's see. Are they going to do something different to the graph?
Yes.
Let's see. Let's put it in our graphing calculator.
Is what if you put it in parentheses?
It just, the exponent would just go to the x and then.
So now I'm going to keep my x squared function. Let's clear out the second one.
I can't believe this.
Now we're going to put parentheses x minus 3. Close your parentheses. And then raise it to the second power. Everybody got this? Now I'm going to make sure my graph is back to Zoom standard because I moved mine all over the place earlier. Okay, so the blue graph is my original. This is the function x squared. The red graph here is the function x minus 3 squared.
Oops.
Because you didn't put in minus.
Positive,
You did the negative, right?
No, x, from that negative. No, I did. Okay, so.
We're just supposed to put X
You gotta hit the
squared.
minus
I
sign.
did that, yeah, I know.
Minus sign, not negative sign.
Yeah, but okay, I put x plus 3 as well, just to see what happens.
Uh-huh.
But why is the negative on the positive line and the...
I was figuring it out.
Everybody get it? Does it look like mine?
Yeah,
That's
but
a
it
good
doesn't
question.
make
Why is
sense.
it put that
No,
there?
I don't like
Silly
Why?
goose.
Yeah, when it goes to the, when you put a negative in, it goes to the right.
Uh-huh.
Positive, when you put a positive in, it goes to the left.
Uh-huh.
Is it because of the exponent and like it's like being multiplied times itself or, you know what I'm saying?
Well, so there's different ways.
Negative times.
There's different ways you can think about why. So if I plugged in, remember, a function, if I don't know what it looks like, I'm just plugging in x values to see what I get out. So if I plugged in 0 for x, what is the y value in this function? What is 0 to the second power? 0. If I plug in 1 to this function, 1 to the second power is 1. So you see how the points 0, 0, 1, 1 are on your graph? If I plug in 2, crazy. 2 to the second power is 4. So the ordered pair 2, 4 is on my graph. If I plugged in 3, 3 to the second power is 9. So 3, 9 is on my graph. So I got a few points here. Now let's plug in these same points to my new function. So if I plug in a 0 for x, well 0 minus 3 is negative 3. Negative 3 squared is positive 9. Okay, now if I plug in a 1, 1 minus 3 is negative 2. Negative 2 squared is 4. If I plug in a 2, 2 minus 3 is negative 1. Negative 1 squared is 1. If I plug in 3, 3 minus 3 squared is 0. Or sorry, 3 minus 3 is 0. 0 squared is 0. So you can see when I plugged in the 3 for x, I got the y value of 0, which used to be the y value when I plugged in 0. And so it is kind of hard in our brains to wrap around what's going on, but I always think plugging in helped me see it the most with what's happening. That here is where I finally get the vertex. Plugging in 3 finally got me to the low point that I used to get with 0. That this -3 has kind of slowed down the graph reaching its vertex by 3. And now it reaches its vertex later. And again, you don't have to really understand that. All you really have to know is that when I subtract 3 on the inside of the function, it's going to go right 3. Right? It goes the opposite of the way it looks like it's going. And that has to do with everything that happens on the inside of the function. Everything on the inside does the opposite of what you think it looks like it should do. So a -3 is going to shift the graph right 3. And a +3 is going to shift the graph left 3. Right? They go the opposite of kind of what your gut tells you it should do. In parentheses to the second power. What's this going to do to the graph?
It's gonna go left 1.
It's going to shift the graph left 1 unit. Again, it does the opposite of what you think it would do naturally. The +1 is going to shift it left 1. So where's the vertex going to be?
0, 1. No.
1, 0. 1, 0.
Yep. Sorry.
Negative 1, 0.
Negative.
Oh my gosh, I don't even know.
Okay, so we obviously need a little bit more thinking through this. X squared normally goes through the origin, 0, 0. You told me this +1 is going to shift the graph left 1. So if I go left 1, then my new parabola is going to be here.
Negative 1, 0.
That order pair is -1, 0. So the vertex is -1, 0.
And the symmetry thing is
And the axis of symmetry, it is x equals -1. Remember, an axis of symmetry is an equation of a vertical line. It's always x equals a number. You have to write all of that. You can't just say -1. Okay, what about the second one? X minus 5 in parentheses, squared.
shift right 5.
This is going to shift the graph right 5. Absolutely. This is going to shift right 5. So where's the vertex going to be if I shift right 5?
5, 0.
5, 0.
An axis of symmetry is going to be x equals 5.
The axis of symmetry will now be occurring at x equals 5. What kind of transformations are occurring on the second graph here?
It's gonna go left,
To the right
right
1
and up 2.
So the -1 on the inside makes us go right 1. The +2 on the outside is going to make us go up 2. So where's my vertex?
1, 2.
It's going to be at 1, 2, right? If you can move it in your head, right 1, up 2 is going to move from 0, 0 to 1, 2. And where's the axis of symmetry?
X equals 1.
It is going to be the vertical line x equals 1.
Are we still being as slow?
Okay, if I look at the last one, The last one says f of x
do
equals
us like
x
that.
plus 2 squared minus 1.
Left 2 and down 1.
Okay? This is going to go left 2 units and down 1 unit.
We just ask questions and talk.
I like it. I'm not mad. Did I say anything? I didn't say anything.
No,
I didn't say a word.
don't say that. No, that chuckle.
Where's the vertex? Where's the vertex?
One, negative two.
Negative 2.
Negative 2, 1.
So again,
Negative 2, negative 1.
I used to be at 0, 0.
You go
If I
left
move
2,
that left 2
and down
and
one.
down 1,
you're negative 2, 1.
I'm at negative 2,
Negative
Negative 1.
Negative 1.
I'm at negative 2, negative 1. Remember, going down is negative.
I'm still getting used to like.
That's okay. That's all right. The axis of symmetry.
Negative 2. Go.
Who?
I missed something big.
What?
It's going to be the equation of the vertical line. It's always x equals a number. Your answer is always x equals a number. X is equal to negative 2. But you can't just say negative 2. That's not an axis of symmetry.
I got something like that wrong yesterday.
Yes, because it's always x equals the number. That's our equation for vertical lines. If I made you identify what transformations have occurred here to the first one, we went right 1, we went down 3, and we also stretched by 2.
Dude, I'm like lazy, you know, so like I'm gonna just put arrows instead. Is that cool?
No.
Okay. Where is my vertex?
It's negative. No, it's positive 1, negative 3. Negative 3. Now I'm mad.
Did the 2 change the vertex?
No.
No. Remember, we did a bunch of stretches, we did a bunch of reflections where it opened down. We did all kinds of stuff with those numbers out front 2 days ago, and we never changed the vertex. So that 2 on the outside did not change it. What about the axis of symmetry?
X equals 1.
X equals 1 is my axis of symmetry. Okay, what about, we don't have to write all these. We're good just writing that one. What happened here? This graph is still going to go right 1,
Up 2.
up 2.
It's gonna be water. It's gonna be compressed.
That's a compression. So instead of using a stretch, we're going to use the word compression.
Flatten it
To
out.
make it wider. Compressed by 0.25.
You know, that doesn't make sense.
What does it make
I
sense?
feel like it should be stretched and that one should be compressed because that's more sense.
No.
No.
If it's decimal, it's gonna be like, you know what I'm saying, like if it's a whole.
Where's the vertex?
Oh, yeah.
Where's the vertex?
1,
2.
1, 2. Yeah.
1, 2. Right, I went right 1, up 2. So I'm at 1, 2. Where's the axis of symmetry?
It'd be
X
1.
equals 1.
X equals 1.
Yeah, X
That's the only thing that moves it. X equals 1. Okay? What's the big thing that's different here?
It's a negative.
There's a negative 0.1. So we are going to go
Left 2.
left 2,
Down 1.
down 1. It's going to be a
compressed.
compression by
Up and
0.1. What's the negative going to do?
It's gonna open it down.
Open down. Remember, if the A term is negative, it's going to make the parabola open down. And so we can put that in our calculator to confirm it. I don't remember what the numbers were. Never mind. I'm not going to put it in there. You can put it in there to confirm it. if you want to. If you put the negative 0.1,
Oh my goodness.
that is gonna open downward. So,
Another form though.
correct. So, this form is a quadratic function, but notice how it's already been factored.
Yeah.
Because this is x plus 1 times x plus 1. Right, you see how this is factored form. We're going to eventually look at quadratics that are not factored
And then we have to factor them.
and graph them. That's where we're going.
So for it to be factored, both of those matching parentheses would have to be x plus 1.
That's
why
correct.
X plus 1 squared.
That's correct.
So it,
The
if
factored
it,
form has a matching
if it
parenthesis.
isn't the same one, then it can't be a fact. Then it can't be factored. Like
Yes. Yes. We're yes. You're right. But let's don't go down that rabbit hole yet.
God, Dave, you know
No.
that.
That's a little bit more time. Okay.
just
Alright.
Mr.
Probably not quite that far.
Probably like next
I'll allow
week.
myself.
So
I swear.
let's graph this without our graphing calculator.
Got you.
Let's make a rough sketch of it without the calculator. Without it. So, what does the parent function look like? We should know what x squared looks like. It's a parabola. That was a really bad parabola.
That was a beautiful parabola.
It's a parabola that's vertex is at 0, 0. Right? That's what x squared looks like. This is my parent function. Now, what all do I have to do to this graph to make it look like negative 2 x plus 1 squared plus 5?
Go left 1, up 5.
Okay, so the plus 1 is going to make me go left 1 unit. The plus 5 is going to make me go
Up 5.
up 5 units.
And then
The
negative
2
is going to open it downwards.
So this is going to reflect the graph.
Yeah, reflect the x-axis.
And the 2 is going to
Stretch it. Zang, bro. Zang. That's a lot.
Good golly.
So the order we need to do this in is actually this way.
Yeah.
Okay? We're going to start with the things that are being multiplied first. Think about your order of operations.
Would you read it left to right? Or
You can. You're going to do everything that's being multiplied
first?
first, and then add or subtract. So if I stretch this by 2, what would that make it look like?
Narrower.
It's going to be narrower.
And it's going to be upside down too.
Yeah. So I've stretched it by 2. Okay. Now I need to reflect that.
Open downwards.
So I need to keep this taller, skinnier version and reflect it.
Now,
Now I need to do what? I need to move that
left 1.
left 1 up 5. So if I go here, I could go left 1 up 5. 1, 2, 3, 4, 5. I'm somewhere here. It's still going to be narrow. I probably made it a little too wide. Alright, but we're just getting a rough sketch today. We're not, it doesn't have to be perfect. I just want you to understand what's happening, what transformations are occurring. We will eventually have to do better sketches, but it's not today.
Good.
I know.
Like what graphing.
On graphic paper.
Yes, we'd have to have graphing paper.
Good, 'cause my-
And we would have to move multiple points. Like right now, the only point I really moved was the vertex. And then I just knew what it looked like around that vertex. Well, if we're going to be precise, we're going to have to move more than,
X plus 4.
we're going to have to move 5 points to get a better
X
shape
plus
of the
20.
graph.
X plus 20 squared minus 45.
Any questions?